Let's learn about Pythagorean triples. You'll be learning about the relationship between the Pythagorean triples and the Pythagorean theorem. Then we learn about primitive Pythagorean triples. Then the formula to generate them. Then we learn some properties of the Pythagorean triples. And finally, we'll understand how to find the Pythagorean triples when one of the numbers is given. So let's get started. This is a right-angled triangle. We have the sides A, B and C. C will be the largest side, the hypotenuse. We know that the Pythagoras theorem gives us the relationship between the three sides of this right triangle. A squared plus B squared is equal to C squared. Now, let's give some values for A, B and C. Let's say we have A is equal to 1 and B is equal to 1. So, according to the theorem, C squared will be A squared plus B squared. 1 plus 1, which is 2. So, the side C becomes square root of 2. Let's consider another set. A is equal to 3 and B is equal to 4. In this case, C squared will be 3 squared plus 4 squared, which is 9 plus 16, and that is 25. C squared is 25, so C will be 5. Now, if we write the sides of the triangle as a set like this, we have 1, 1 and root 2 here. And in this case, we have 3, 4 and 5. Now, we can say that if the three sides of the right triangle satisfy the Pythagorean theorem and they are all integers, then it becomes a Pythagorean triple. So, in this case, 3, 4, 5 will be a Pythagorean triple, but 1, 1 and root 2 is not a Pythagorean triple because root 2 is not an integer. So, simply put, a Pythagorean triple is made up of three positive integers A, B and C such that A squared plus B squared is equal to C squared. Next, we'll see what happens when we multiply the three numbers with a common number. For example, let's take 3, 4 and 5. On multiplying all the terms by 2, we get 6, 8 and 10. 6 squared is 36 and 8 squared is 64. When you add them, you get 100, which is 10 squared. So, this again becomes a Pythagorean triple. In the same way, you can multiply it by 3 to get 9, 12 and 15. With 4, we get 12, 16 and 20. This can go on. Let's understand here that these two sets are also Pythagorean triples. 9 squared is 81, 12 squared is 144 and adding them, we get 225, which is 15 squared. Similarly, you can check for this one as well. Now listen carefully. Among all of these Pythagorean triples, this one will be considered as a primitive Pythagorean triple, which is because 3, 4 and 5 are co-prime, which means they do not have any common divisor. Now coming to these three triples. When we divide all the three terms by the greatest common factor, we will end up with the primitive Pythagorean triple. Next, we have a total of 16 primitive Pythagorean triples of numbers up to 100. There are still many more which are greater than 100. Now, let's learn how to generate Pythagorean triples using a formula. A is equal to m squared minus n squared. B is equal to 2mn. And C is equal to m squared plus n squared. This is called as the Euclid's formula, and it is used to generate the Pythagorean triples with any given pair of integers m and n, where m is greater than n and both of them are greater than 0. So let's consider our first example. M is equal to 2 and n is equal to 1. These are the smallest integers that satisfy our condition. So let's find out. A is equal to m squared minus n squared. 4 minus 1, which is 3. B is equal to 2mn. 2 into 2 into 1, and that is 4. C is equal to m squared plus n squared. 4 plus 1, which is 5. So we have the triplet 3, 4, 5. We already saw that these numbers satisfy our Pythagorean theorem. Now, let's check out one more example. M is equal to 3 and n is equal to 2. Now, A becomes 9 minus 4, that is 5. B is equal to 2 into 3 into 2, which is 12. And C is equal to 9 plus 4, and that is 13. So our next set is 5, 12 and 13. Let's verify if this satisfies the Pythagorean theorem. A squared is 25, B squared is 144 and C squared is 169. 25 plus 144 is 169. So these numbers will form a Pythagorean triple. Now let's learn the proof for this formula. We know that A squared plus B squared should be equal to C squared. First, let's find A squared plus B squared. M squared minus n squared, the whole squared, plus 2mn the whole squared. That is equal to m to the power of 4 minus 2m squared n squared plus n to the power of 4 plus 4m squared n squared. That becomes m to the power of 4 plus 2m squared n squared plus n to the power of 4. Now let's find out c squared. That is m squared plus n squared the whole raised to 2, which is m to the power of 4 plus 2m squared n squared plus n to the power of 4. These two become equal and hence proved. Now let's learn some properties of primitive Pythagorean triples. Exactly one of A or B is divisible by 2. Here we have the first few Pythagorean triples. On looking at A and B values, we can see that only one among them is divisible by 2. Next property. The hypotenuse C is always odd. Again, among these examples, C is always an odd number. Next property. Exactly one among A and B is divisible by 3 but never C. First let's check all the C values. None of them are divisible by 3. Then we'll come to A and B. In each of the given sets, only one number is divisible by 3. The next property, exactly one of A and B is divisible by 4 but never C. Since we know that C is always odd, we can confirm that C can never be divisible by 4. But again, among A and B, only one of the number is divisible by 4. And the last property, exactly one among A, B and C is divisible by 5. On going through these examples, one among the 3 numbers in every set is divisible by 5. With that, we come to the final part of the session, finding the Pythagorean triple when one of the number is given. Here we'll study 2 cases. First, when the number is even. For example, find the Pythagorean triple when one of the number is 6. Before getting started, let's quickly recollect the formula to find the triples. A is equal to m squared minus n squared, B is equal to 2mn and C is equal to m squared plus n squared. Now listen carefully. When you have these kind of questions, let's keep n as 1. So the formula becomes A is equal to m squared minus 1, B is equal to 2m and C is equal to m squared plus 1. Now coming to our question. The given number is 6. If we assign this number to B, we can get the value of m to be 3. And since you have the value of m, we can find the value of A, which is m squared minus 1. So A is 9 minus 1, A is equal to 8. And C becomes 9 plus 1, which is 10. So our Pythagorean triple will be 8, 6, 10. Let's arrange it in ascending order. 6, 8, 10 is the answer for this question. Now let's see what happens when we are given an odd number. For example, find the Pythagorean triple when one of the number is 5. Here, let's understand that b has to be a multiple of 2. So let's multiply this number 5 with 2 to get 10. So if b is equal to 10, m will be half of b, 5. A is m squared minus 1. 25 minus 1, a is equal to 24. C is m squared plus 1. 25 plus 1 is 26. So our triple will be 24, 10 and 26. Arranging it in ascending order, we get 10, 24 and 26. But this is not the answer. We need the triple when one of the number is 5. When you look at the triple, you can find that all of the numbers are multiples of 2. So let's divide them all by 2. We get 5, 12 and 13. This is the final answer. If you have understood this concept clearly, try to find the solution for these questions and let me know in the comments.